Welcome class 12th. Today I am going to start our new topic colloids. So let's start. Colloids. Colloid is a state of a substance which depends upon the molecular size. That's too important that it is the state of a substance which depends upon molecular size. On the basis of particle size of the substance, the solution may be divided into three types. And the three types are: one is true solution, second is colloidal solution, and third one is suspension. To understand these three types of solution, first of all, suppose I have a beaker containing water, and in this beaker, suppose I add to this beaker, I add some NaCl particles to this. I add some salt to this beaker. Now after shaking and on shaking, what I will get a uniform solution of salt and water. It means if I shake this salt with water, I will get a uniform solution, a homogeneous mixture in which the particle size of solute is very small. So such type of solutions are known as true solution. And similarly, if I take second beaker which is having water, which contains water, and in this beaker, if I add some sand to this, if I add some sand particle to this water, now what will happen on shaking? If I add sand molecules to this water on shaking, those sand particles will not get dissolved to the water, and they will get suspended through the solution, and the solution which I will get after shaking, that solution will not be uniform. And such type of solutions are heterogeneous solution. We are familiar with heterogeneous solutions, solutions which are not uniform throughout the mixture. And as it is not uniform, it means why it is not uniform? Because its solute size is very large. That's why it will be not uniform. It is not dissolved in the water, and we can see those solute particles even with our naked eyes. And at the same time, if I will take the third type of the beaker and in which water is present, and to this water, if I add some starch, now what will happen? Starch particle on dissolving with water, the molecules are again dispersed in water, and they are dispersed in a heterogeneous form. They are not uniform. As they are not uniform, but their particle size will be less than the particle size of sand. And the particle size of starch molecule cannot be seen by the naked eye, but can be seen by the microscope. So from this concept, from these effects of these three different beakers, we can conclude that in this very first beaker where we added NaCl, we get a uniform solution. It means it is a true solution, where the particle size is very less. In true solution, from the conclusion, we can conclude that in true solution, the particle size is less than 1 nanometer, which cannot be seen by the naked eyes, even by the microscopes. And in third beaker, where we added sand, in such type of conditions, the particle size is always greater than 1000 nanometer, 10 to the power 3 nanometer. It means they have very large particle size. And now if we come to the second type of the beaker, this where we added starch molecule, in the second type of the beaker, the particle size will lie in between 1 to 1000 nanometer. 1 to 10 to the power 3 nanometer. It means such type of solutions are known as colloidal solutions. कोलॉइडल सॉल्यूशंस उन सॉल्यूशन को बोलेंगे जिनका पार्टिकल साइज 1 नैनोमीटर से 1000 नैनोमीटर के बीच में लाई करेगा. इसका मतलब जो ट्रू सॉल्यूशन एंड सस्पेंशन, इन दोनों के बीच में जिनके पार्टिकल मॉलिक्यूल का साइज होगा, सच टाइप ऑफ सॉल्यूशंस आर नोन एज कोलॉइडल सॉल्यूशंस. And this can be seen by this table also. The true solution, if we compare these three solutions, then the true solutions are those which is homogeneous solution, which contains small solute particles dispersed through a solvent, and whereas colloidal solution is a heterogeneous solution, and suspension is also a heterogeneous mixture which contains insoluble particles. ट्रू सॉल्यूशन पार्टिकल साइजेस लेस देन 1 नैनोमीटर, जो अभी हमने डिस्कस भी करा, जो ट्रू सॉल्यूशंस होते हैं उनका पार्टिकल साइज लेस देन 1 नैनोमीटर होता है. कोलॉइडल सॉल्यूशन का पार्टिकल साइज 1 to 1000 नैनोमीटर के बीच में लाया करता है, एंड सस्पेंशन के पार्टिकल साइज मोर देन 1000 नैनोमीटर होता है. ट्रू सॉल्यूशन में जो पार्टिकल्स होंगे सॉल्यूट के वो इनविजिबल होते हैं इवन अंडर माइक्रोस्कोप. कोलॉइडल सॉल्यूशन के जो पार्टिकल्स होते हैं नॉर्मली सीन विथ कैन नॉट बी नॉर्मली सीन बाय नेकेड आइज, एंड जो सस्पेंशन के पार्टिकल्स होते हैं उनको हम नेकेड आइज से इजीली हम उन्हें देख सकते हैं. एग्जाम्पल हमने ट्रू सॉल्यूशन का देखा NaCl इन वाटर, कोलॉइडल सॉल्यूशन का लाइक मिल्क स्टार्च इन वाटर, एंड सस्पेंशन के लिए सैंड इन वाटर. This can be seen by the image also. Here the true solution size is less than 1 nanometer, suspension size is greater than 1000 nanometer, and for colloidal solution size in between 1 to 1000 nanometer. So from here the conclusion we can conclude that the colloidal solutions are intermediate between the true solutions and suspensions. Now come to the next phase of colloids. Colloid contains two phases. One is known as dispersed phase and another is known as dispersion medium. Dispersed phase is the component present in small proportion and is just like a solute in solution. If we are talking about solution, the solute part in the solution is in a small proportion. Similarly, dispersed phase of a colloid is the component, it is the phase when the component present in a smaller proportion. And dispersion medium, it is the component present in excess and is just like a solvent in a solution. क्योंकि हमें पता है हमने solution में पढ़ा हुआ था, solution के भी दो पार्ट से मिलके बना हुआ होता है, solute and solvent. Solute part smaller part होता है, solvent part larger part कहलाता है. Similar way में dispersed phase of colloid is a smaller proportion and dispersion medium because it is a medium which is providing a medium, and this medium will be of which is present in a excess form. This can be seen by the image also. Suppose if we have a mixture of oil and water, so in that case water will be considered as dispersion medium and oil will be considered as dispersed phase, which is in lesser amount dispersed phase, those which is in larger amount dispersion medium. Now come to classification of colloids. Colloids are classified on the basis of the following criteria. First is physical state of dispersed phase and dispersion medium, nature of interaction between dispersed phase and dispersion medium, type of particles of the dispersed phase. First of all, on the basis of physical state of dispersed phase and dispersion medium, depending upon whether the dispersed phase and dispersion medium are solids, liquid or gases, 8 types of colloidal systems are possible. On the basis of physical state of a dispersed phase and a dispersion medium, there are 8 types of colloidal systems which are possible. And it may be noted that when a gas mixed with another gas forms a homogeneous mixture and hence it is not a colloidal system. अगर हमारे पास में एक गैस है, dispersed phase dispersion medium भी गैस है, तो ये जो मिक्सचर होगा दो गैसेस का, that mixture will be a homogeneous mixture and that will not a colloidal system, because we know that colloidal systems are heterogeneous in nature, so a homogeneous mixture of two gases cannot be a colloidal system. So types of colloidal systems. This can be seen by the table. If we have dispersed phase as solid, these three phases are of solid, these three dispersed phases are of liquid, and only two phases for gases are here. And if dispersion medium is for solid dispersed phase, dispersion medium is solid, then that type of colloid are known as solid colloid. And example for such type of colloid is ruby glass, gemstones. These are the example of solid dispersed phase, solid dispersion medium. When dispersed phase is solid but dispersion medium is liquid, then such type of colloid is known as sol. Example for these are paint or gold sols. If dispersed phase is solid, dispersion medium is gas, then such type of example is aerosol, smoke. That type of colloid is known as aerosol, where the dispersion medium is gas, and the examples are smoke, dust, storm, haze. Next, when dispersed phase is liquid, dispersion medium is solid, then the form type of colloid is known as gel. When dispersion medium is solid and dispersed phase is liquid, then type of colloid is gel, like jelly, butter, cheese. When both dispersed phase and dispersion medium both are liquid, then the type of colloid is known as emulsions, like milk, medicines, they are emulsion. Both dispersed phase and dispersion medium are liquid in this case. When dispersed phase is liquid but dispersion medium is gas, again the type of colloid is known as aerosol. When the dispersed medium is gas, then the type of colloid is known as aerosol. You can see in both the cases here where the dispersed phase is solid and dispersed phase is liquid, but dispersion medium is gas, the type of colloid is known as aerosol. And for this particular example of where dispersed phase liquid, dispersion medium gas, example is fog, mist, cloud. And if dispersed phase is gas but dispersion medium is solid, such type of sols are known as solid sols. Example for such type of colloid is pumic stone. And dispersed phase is gas but dispersion medium is liquid. A colloid type of colloid is foam, leather, soap leather, foam, whipped cream. Now come to the second part of the classification, nature of interaction between dispersed phase and dispersion medium. जब डिस्पर्स फेज और डिस्पर्जन मीडियम उन्हीं के पार्टिकल्स के बीच में जब उसका इंटरेक्शन हम देखेंगे, उनके नेचर के इंटरेक्शन के बेसिस पे कोलॉइडल सोल्स कैन बी डिवाइडेड इनटू टू कैटेगरीज. वन इज लायोफिलिक, solvent attracting, and lyophobic, solvent repelling. First of all, we will discuss lyophilic colloids. Philic. The word lyophilic means liquid loving. Lyo means liquid, philic means affection or love. So the word lyophilic means liquid loving. The colloidal solution in which the particles of dispersed phase have a great affinity for the dispersion medium. So such type of colloidal solution forms are known as lyophilic colloids. And in these solutions, these are easily formed by direct mixing. This is their ease of preparation. They can be easily formed by direct mixing. Why? Because they have great affinity of dispersed phase and dispersion medium. And these are reversible in nature. Also, these are stable in nature. Why? Because they can easily be formed. So these are stable in nature because affection between dispersed phase and dispersion medium is more in case of lyophilic. Now come to the next, lyophobic colloids. The word lyophobic means liquid hating. Again, lyo means liquid, phobic means phobia, hate. So lyophobic means liquid hating. The colloidal solutions in which the particles of dispersed phase have no affinity for the dispersion medium. Whereas in lyophilic, as we have discussed that dispersion medium and dispersed phase has great affinity. But in case of lyophobic, there is or there is no affinity between dispersed phase and dispersion medium. And these salts are radially precipitated on the addition of small amounts of electrolytes by heating or shaking. Therefore, these are not stable. These are irreversible in nature. Once precipitated, cannot form a colloidal salt by simple addition of dispersion medium. These are formed only by special methods. Come to the third type of classification, which is based on types of particles of dispersed phase. On the basis of this classification, colloids can be divided into three parts. One is multimolecular colloid, macromolecular colloid, and associated colloids. First of all, multimolecular colloids. On dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form a species having a size of the colloidal range 1 to 1000 nanometer. The species thus formed are called multimolecular colloids. When large number of atoms or the smaller particles they get combined together to form a larger molecule of having size in between 1 to 1000 nanometer. So such type of molecules are known as multimolecular colloid. Example for this, sulfur sol, which consists of particles of 1000 or more of acid molecule of sulfur. As we know that sulfur has acid molecule like structure. So if sulfur sol which is containing of 1000 or more of acid molecules and they form a colloid of sulfur which is known as sulfur sol. So this is a multimolecular colloid. Come to macromolecular colloids. Macromolecular colloids, these are the substances having big size. Macro means big. Macromolecule, which on dissolution form a solution in which the dispersed phase particles have size in the colloidal range. When they form a bigger particle and that particle size has the size in between the colloidal range, it means in between 1 to 1000 nanometer. Example, macromolecules like naturally occurring macromolecules are cellulose, starch, proteins, enzymes, etc. These all are naturally occurring bigger molecules or macromolecules. Whereas some artificial macromolecules are polymers. Poly means large. Polymers such as polythene, nylon, polystyrene, etc. Now come to third type of the colloid, that is associated colloid. There are some substances which at low concentration behave as normal strong electrolyte but at higher concentration exhibited as colloidal behavior. So due to the formation of that aggregates, the aggregated particle are known as micelles. And that micelle is called as associated colloids. The cluster micelles are the cluster particles formed by the association of colloids in solution. Example of micelle are soaps, detergent. We are familiar with the example of micelles, and the formation of micelles takes place only above a particular temperature, and that temperature is known as Kraft temperature. And above a particular concentration, that concentration is known as critical micelle concentration. So formation of micelle have two categories, that above particular temperature micelles are formed and that temperature is known as Kraft temperature, and above a particular concentration, it means here if the concentration of a strong electrolyte is above higher concentration, so the formation of a colloidal behavior takes place and that colloids are known as micelles. अगर टेम्परेचर नॉर्मल इलेक्ट्रोलाइट का जो कॉन्सेंट्रेशन है वो उससे ज्यादा कॉन्सेंट्रेशन में की अगर हम बात करें, उस इलेक्ट्रोलाइट का कॉन्सेंट्रेशन ज्यादा हो जाए तो वो इलेक्ट्रोलाइट की तरह बिहेव ना करके कोलॉइड की तरह बिहेव करता है, तो वो क्या बनाते हैं, एक मिशेल फॉर्मेशन करते हैं और उस मिशेल का जो अबव कॉन्सेंट्रेशन हो गया, जिस हायर कॉन्सेंट्रेशन पे वो मिशेल बने, उस कॉन्सेंट्रेशन को बोलते हैं क्रिटिकल मिशेल कॉन्सेंट्रेशन. फॉर सोप्स, critical micelle concentration CMC is 10 to the power -4 to 10 to the power -3 mole per liter. And on dilution, if it decreases the concentration, it means on dilution these colloids revert back into ions. We know that क्योंकि कोई भी हमारे पास स्ट्रॉन्ग इलेक्ट्रोलाइट होगा, जब तक उसका नॉर्मल कॉन्सेंट्रेशन है तो वो इलेक्ट्रोलाइट की तरह बिहेव करता है, आयंस की तरह बिहेव करता है. लेकिन अगर कॉन्सेंट्रेशन बढ़ जाता है तो वो आयंस एग्रीगेट होके एक बड़ा मॉलिक्यूल बना देते हैं जिसको हम कोलॉइड कहते हैं. और यहीं पे अगर हम डाइल्यूशन करेंगे तो कोलॉइड के पार्टिकल्स, डाइल्यूशन करने का मतलब कॉन्सेंट्रेशन को कम करना. कॉन्सेंट्रेशन हाई होने पे तो कोलॉइड बना था, लेकिन कॉन्सेंट्रेशन को अगर हम कम कर देंगे तो डाइल्यूशन होने पे वो क्या हो जाएंगे, फिर से अपने इंडिविजुअल आयन में कन्वर्ट हो जाएंगे, फिर से अपने इंडिविजुअल आयन को बना देंगे. सो these colloids have both lyophobic and lyophilic parts. Micelles may contain as many as 100 molecules and more. So here, mechanism of micelle formation. Let us take an example of soap solution. Soap is a sodium or a potassium salt of higher fatty acid and may be represented as RCOONA or K positive. For example, sodium citrate. Example of sodium citrate is given here, and it contains a long chain hydrocarbon which is denoted by R. It is a non-polar part and it is known as tail, and in which which is hydrophobic. This hydrocarbon part is hydrophobic in nature, means water repelling. Hydro means water, phobic means repel or hate, water repelling. And the polar group is CO negative. In this salt part, polar group is CO negative, which is also known as polar ionic or known as head, which is hydrophilic. Hydro means water, philic means affection or love. It means it is water loving. Now what will happen, this can be seen in the image also, as we have this dust part is here or the oil phase is here. Now what will happen, the hydrocarbon part or the tail part will move away from the water. It will be moved away from the water part, and the water part and the head part or the polar ionic part will attach to the water part. जो हाइड्रोकार्बन पार्ट होगा वो जाके अटैच हो जाएगा, जो भी डर्ट पार्ट है या जो भी ऑयल फेज है उस पे जाके अटैच हो जाएगा हाइड्रोकार्बन पार्ट, क्योंकि वो वाटर के साथ तो नहीं उसने अटैच होना है, वो एक हाइड्रोफोबिक है नेचर में. वहीं पे जो पार्ट हाइड्रोफिलिक है वो जाके अटैच हो जाएगा वाटर में. तो ये जो पूरा प्रोसेस होगा, ये प्रोसेस वर्क करेगा एज अ मिशेल का फॉर्मेशन होगा, और ये जो एक स्फेरिकल फॉर्म हुआ है, एक स्फेयर फॉर्म हुआ है, दैट स्फेयर इज नोन एज अ मिशेल. और इसी के तरह वर्क करता है सोप का क्लींजिंग एक्शन. जो सोप है वो क्लीन करने के लिए, क्लोथ्स की क्लीनिंग के लिए, डर्टी क्लोथ्स होंगे उनकी क्लीनिंग के लिए यूज होता है क्लींजिंग एक्शन सोप के लिए. So that's all for today. Now I have some solved questions for you. Go through these questions. Some question answers are for you. First question is, why are lyophilic colloidal sols more stable than lyophobic colloidal sols? Now answer is because in lyophilic sols there is more affinity between dispersed phase and dispersion medium, or they are highly hydrated in solution. That's why the stability of lyophilic colloidal sols is more as compared to lyophobic colloidal sols. Because in case of lyophobic colloidal sols, the affinity between dispersed phase and dispersion medium is very less, and even no affinity between dispersed phase and dispersion medium, so their stability is also less or decreases as compared to lyophilic colloidal sols. Second question is, what is the difference between a sol and a gel? Now, in a gel, dispersion medium is liquid and dispersed phase is solid. When dispersion medium is liquid, when medium is liquid and the phase is solid, then the formation of a colloid, that colloid is known as sol. Whereas in a gel, when dispersion medium is solid, when medium is solid but the dispersed phase is liquid, then the colloid which is formed is known as gel. So in case of gel, dispersion medium is solid and dispersed phase is liquid. So that's all for today. We will meet in our next video with next topics. Thank you.